Hi, welcome back to the all-in-one certification video series. I'm Mike Redmond, Master Trainer, here to guide you through your successful journey of becoming a Security Plus certified professional. We're going to walk through a variety of subjects like access control and encryption, all the way down to network security and hardening the OSs. In this section, we will define vulnerability assessment and explain why it is important, list vulnerability assessment techniques and tools, explain the difference between vulnerability scanning and penetration testing, and list some of the techniques for mitigating and deterring attack. Starting with vulnerability assessments. A vulnerability assessment is a systematic evaluation of asset exposures. The aspects of a vulnerability assessment include asset identification, threat evaluation, vulnerability appraisal, risk assessment, and overall risk mitigation. When identifying assets, it's simply the process of inventorying items with economic value. Some common assets are people, data, hardware, and software. Next, you need to determine each item's relative value. How difficult is it to replace that asset? And then you'll use a rank or numbering scale to identify the need of protection. When performing vulnerability assessments, remember what you're doing is threat evaluation. You're listing all known potential threat. You'll use several different techniques such as threat modeling. The goal there is to understand attackers and their methods. It's often done by constructing scenarios. You can build an attack tree. This provides a visual representation of potential types of attacks. Some categories of threats that you need to take into account are natural disasters, espionage, extortion, human error, software attacks, threat, and so on. Here's a look at a typical attack tree, for instance, for stealing a car radio. Next, you look at your vulnerability appraisal. Determine the current weakness. It's a snapshot of the current organization's security. Then catalog each vulnerability. You'll want to perform next your risk assessment. Determine damage resulting from an attack and assess the likelihood that vulnerability is a risk to that organization. Remember, not all vulnerabilities are risk. They're two different things, and it's important for you to keep them separate in your mind. When looking at potential impact, you'll look at no impact all the way up to catastrophic impact. This is why it's important to structure them and rank them so you know which assets to expend resources to protect. You'll do this by estimating the probability that the vulnerability itself will actually be realized. Once you can do that, you can then determine risk mitigation. Determine what to do about the risks. Do you diminish the risk, transfer the risk, or just accept the risk? When looking at these types of techniques, it can all start really with the assessment technique itself, such as baseline reporting. This is comparing the present state to the known or should be known baseline. The baseline is simply the standard for solid security, or what the organization has established as the standard. You need to look at different application development techniques or software development life cycles. This has several challenges to it. Software application size and complexity, the lack of security specifications for different types of software languages, and it's hard to indicate the future attack techniques because they're widely just unknown. This is why the software development process is so important. You should be conducting regular design reviews, code reviews, and create and distribute security updates as required. Next, let's look at some different type of assessment tools. What are these tools doing? They're basically using IP addresses to uniquely identify each network device, generally by TCP/IP communication. They're also going to map individual ports and protocols, unique identifiers for applications and services, generally identified in 16-bit lengths. There are several different types of ports to realize: the well-known port numbers, registered port numbers, and then those identified as dynamic or private port numbers. The well-known port numbers are reserved for most universal applications, where registered port numbers are other applications not as widely used, and the dynamic or private ones are available for any application to use at any time. Here's a look, for instance, of some well-known port numbers. The Security Plus examination expects you to know and be able to recognize most of the common well-known port numbers. It's important when employing these assessment tools that the operator has knowledge of what port is being used, and can it be used by an attacker to target a specific service or device. To do this, we use port scanner software. It searches the system for port vulnerabilities, used to determine the port state, whether it's open, closed, or blocked. Next, we'll use protocol analyzers, hardware or software that captures packets across the networks, also known as sniffers. Common uses of protocol analyzers by the administrators is for network troubleshooting, and for security administrators to do overall security analysis. However, the attacker can use the protocol analyzer to display content of each transmitted packet. Vulnerability scanners are products that look for vulnerabilities in networks or systems. Most maintain a database categorizing vulnerabilities they can detect. Examples of vulnerability scanner capabilities are to alert when new systems are added to the network, or maintain a log of all interactive network sessions. They can even track which systems communicate with other internal systems. The problem with these assessment tools is there was really no standard for collecting, analyzing, and reporting vulnerabilities. That's why the OVAL standard was adopted, the Open Vulnerability and Assessment Language. It was designed to promote open and publicly available security content. It standardizes information transfer across different types of security tools and services. Next, we have honeypots and honeynets. A honeypot is a single computer protected by minimal security, with its ultimate goal to trick attackers into revealing their techniques of attack. A honeynet is much the same. It's generally several honeypots put together, or a network of systems with the same end goal in mind. Next, let's take a look at the differences of vulnerability scanning versus penetration testing. A vulnerability scan will create a report of potential exposures, usually using automated software that searches a system for well-known security weaknesses, usually performed from the inside of the security perimeter and does not interfere with normal operations. Whereas pen testing or penetration testing is designed to exploit a system weakness, usually from the outside. It is usually conducted by an independent contractor and may disrupt network operation. The end result should be a penetration test report. There are several different types of penetration testing: black box testing, white box testing, and gray box testing. Black box testing, the tester has no knowledge prior to the actual event, where white box testing, the tester has an in-depth knowledge of the network and systems being tested. And then, as you can probably guess, gray box testing is somewhere in between. Next, we'll talk about mitigating and deterring attack. Some standard techniques for mitigating and deterring attacks are creating an overall security posture by configuring controls and hardening systems, as well as different reporting methods. The security posture describes the strategy regarding the security. The initial baseline configuration is what the systems will be evaluated against. Continuous security monitoring regularly observes systems and networks. Remediation is simply as vulnerabilities are exposed, you put a plan in place to address them. Some might call those POAMs, or plans of actions and milestones. Next, properly configuring controls is key to mitigating and deterring attack. Some controls are for detection, like a security camera. Some controls are for prevention, like a security guard or a fence. There are also information security controls. These can be configured to detect attack and sound alarm or prevent attacks. Some additional considerations when designing and configuring your security controls is whether they should fail open or fail secure or fail safe. For instance, a fail open lock unlocks doors automatically upon failure, whereas a fail safe lock will automatically lock the doors. These are the highest security level for door locks and buildings that have a high secure requirement. Next would be hardening. The overall purpose of hardening is to eliminate as many security risks as possible. You can do this by disabling unnecessary accounts and disabling unnecessary services and protecting accounts with strong passwords. And then finally, reporting, providing information regarding events that occur, whether they're alarms or alerts. Sounding warning is specific situation that occurs, like too many failed password attempts. Or reporting can provide information on trends. It can indicate a serious impending situation, like multiple user accounts experiencing multiple password attempts.
There you have it. Pretty simple, right? I told you it was. I know, it seems like a lot of information all at once, but remember, study hard. Lots of practice questions, and you will succeed. You will become a Security Plus certified professional. I'll see you next time.